for what are the objectives for this course, right? So main objective is to make you stand out in the crowd of all the fresh engineers right out of the college, right? And another thing is to make a novice aware about the conceptuality of bridge engineering and design, and to train him or her step by step from analysis to final design of a bridge. What we are uh, what we are trying to do is that, make you make you aware about how exactly how exactly you can uh, plan, analyze, and design a bridge, right? Of course, with experience, you will get better. There is no alternative for experience. But what we are trying to do to make you get into that threshold, get over that threshold, so you can enrich your career with experience. So this is the main objective of this course. And prerequisite for this course is that first you have to be well versed with the manual structure analysis method. If you don't know about manual methods, no software in the world can help you, right? No software can up till now, no software can uh, replace an engineering judgment from a human mind. So you have to know, you have to be well versed, just not just know, you have to be well versed with the methods, manual methods of structure analysis. And if you are not, if you don't think you are well versed, I suggest you start practicing those methods on the side in order to get maximum from this course. And another most important thing is that you have to be in possession of relevant codes. When I will give the codes we are using. I will provide it in next classes, not in this demo class, but whatever those codes are, and you can find out these codes online. It's not about if I have to provide you a list and then only you can get it. So you have to have IS codes as well as IRC codes uh, in order to get maximum from this coursework. Now this is a 30 days course, so roughly 4 weeks. What we are going to do, what is going to be the flow of this course? Let me explain it to you. First and second week, introduction, a little bit history about bridges, a very brief introduction of evolution of bridges, then loading standards, what loads should be considered and how to calculate it and where to get these loads from. Then reinforced concrete slab bridge decks. That's as far as I am concerned, this is the most important part of of this course. RC, reinforced concrete slab bridge decks. Then comes box culvert. After that comes prestressed concrete bridges, which is, you can see them all around you these days as the infrastructure in the country is booming. Then second and third week, again in second and third week, we are going for the design, individual bridge design. So bridge bearings, piers and abutments, bridge foundation. And last week is going to be about analysis and design of a bridge using SAP 2000. So this is how the workflow for this course is. Okay, yeah. So, sorry, I skipped this slide. In third week, we have wind and seismic loads. Next is, now what is a bridge and its evolution? What exactly is a bridge? We all know what a bridge is, but if we have to define it Okay, hold on. Okay, so here is the thing. What exactly is a bridge? Bridge क्या होता है? Or how bridge evolves to its present state. So what exactly is a bridge? Bridge is a crossing over किसी भी किसी भी बाधा को क्रॉस करने के लिए एक crossing which is a bridge. But if we are talking, if we want to define it in engineering terms, so what is a bridge? Is a bridge is an arrangement made to cross an obstacle in the form of low ground or a stream or a river or any gap without closing the way beneath. ब्रिज क्या है? ब्रिज एक व्यवस्था है किसी भी बाधा को क्रॉस करने के लिए. किस फॉर्म में होगी वो बाधा? लो ग्राउंड, कोई गहरी घाटी है जिसके अंदर से या तो स्ट्रीम जा रही है, गुजर रही है, या नदी गुजर रही है, या किसी भी तरह का एक गैप है. वी जस्ट हैव अ गैप in the alignment of a road. You have to go over this gap. आपको वो gap पार करना है. You have to move on to other side, but without closing the way beneath. नीचे जो भी structure है, whether it's a drainage structure or it's some sort of another structure, you don't have to close that structure. वो जो उसका movement नीचे जिस भी चीज का movement है वो बना रहे. That is what actually bridge as per an engineer is. It's an arrangement. Now a little bit a brief history of bridge. So the thing is that bridge engineering, the evolution of bridge is very closely related to the uh, to our progress, how human civilization progress relative in relation to the time, and along with this the bridge engineering evolves. Bridge structures and bridge spans. Bridge structures and bridge spans were and are presented as civilizational and scientific prowess of an era, right? कोई ब्रिज का स्पान कितना है, या उस ब्रिज को कैसे उसको उस स्ट्रक्चर को कैसे बनाया गया है. अगर वो इफ वी कम टू नो कि मिडिवल एजेस में और इवन प्री एंशिएंट टाइम्स में इस तरह से ब्रिज बनाया गया, या इस तरह का ब्रिज हमें फलानी जगह मिलता है, रोमन ब्रिजेस की बात होती है. सो वी आर इन ऑ के किस तरह से उस जमाने में ये काम किया जा सकता था. इट इज पॉसिबल टू कंस्ट्रक्ट अ ब्रिज ऑफ दिस मच स्पान. सो व्हाट वी गेट इज, हमें ये एहसास होता है कि उस पर्टिकुलर एरा में साइंटिफिकली और सिविलाइजेशनल पॉइंट ऑफ व्यू से हमारे एंसेस्टर्स कितना आगे थे, राइट? सो इट्स लाइक अ माइलस्टोन. The bridge structures, there are so many bridge structures around the world from different era, and these structures are like milestone. The oldest bridge still standing is a pedestrian stone slab bridge dating back to at least 2800 years old. Oldest bridge to the known history is 2800 years old. So you can imagine, you can get the idea how old bridge as a structure exists. कितना पीछे से इसके ऊपर काम किया जा रहा है, और how much important it is for us humans to get over these obstacles in a form of bridges. कितना जरूरी है point A से point B पर जाना, उस बाधा को क्रॉस करके जाना, right? Next is, India was the birthplace of wooden cantilever bridges in the Himalayas. You can see in this figure, this is what we call wooden cantilever bridge. How exactly this bridge is? You can see that they have these structures on either side of the stream of this what is this, a mountain river they have. And then what they do is they inserted these logs, एक कैंटिलीवर तैयार किया गया और फाइनली वो कैंटिलीवर इतना आगे लेकर गए वो लोग कि with just with a single plank you can put on a single plank and you can get on the other side. This, to us right now, this is a very crude form, but back in the day and still now, in some places these bridge makes the difference of life and death. Of course you can't cross this bridge on a vehicle. This is a pedestrian bridge. So this is the form of wooden cantilever bridge you can still find in Himalayas. Next is these Roman bridges. What is unique about Roman bridges is that they they use stone arches using massive piers. These are, I'm sure you all are aware that these are arches, and these arches, where these arches are resting, they are resting over these massive piers. This is what we call pier. You can know more about this terminology when we move into components of bridges. So this is what we call pier, and these massive, the deck of the bridge rests upon these piers via, and the bearing is these arches. इन arches के ऊपर आपका जो bridge का deck है वो टिका हुआ है, and by use of this method Romans were able to cross large spans. Now let's move on into modern times. Pardon? Let's move into modern times. In modern times, the first treatise on bridge engineering was published in 1714 by the French engineer Robert Guite. So this is the first written, you can say, literature on bridge from modern times. And next, in 19th century, with the advent of industrialization and again colonization, demand for stronger and bigger bridges over large rivers resulted in the use of cast iron and wrought iron replacing timber and stones. Last two bridges, the one in Himalaya and one in the Roman world, you can see they are using timber and they are using stone. But with the advent of modern era and industrialization and everything, you need to, the demand for stronger and bigger bridges over large rivers. What does it do? It replaces this timber and stone with cast iron and wrought iron. This is a brief history about the evolution of bridges. Next, classification of bridges. How can you, how many types you can classify a bridge? There are so many criteria to classify a bridge. I am stating a few which I thought is important for this course. First of all, as per flexibility of superstructure, जो आपका superstructure है, जो deck है bridge का, on which you are crossing, on which you are walking, or on which you are driving, that is what called superstructure. As per flexibility of superstructure, fixed span bridges and movable bridges. Fixed span bridge, A to B, point A to B a bridge जा रहा है, that's it. It's a fixed span bridge. Most of the bridges are fixed span bridges, right? Then comes movable bridges. You don't find movable bridges are not that more often. It is more for military purpose, these movable bridges. So it's just a classification. We don't have to go into movable bridges. Next, as per interspan relations, simple bridges, interspan relations, right? What exactly is, now this is span. From this point to this point, this is span. There is only one span, you can say. In this case, it's a small mountain stream, so there is only one span. Here you can see, जितना मैं देख सकता हूँ, जो हमें दिख रहा है उसके हिसाब से there are 1 2 3 4, 5, 6, and so on. So these are called spans. So as per interspan relation, there is simple bridge, then there is continuous bridge, and then there is cantilever bridge. Next comes as per the type of superstructure. As per type of superstructures, we have arch bridge, we have bowstring girder bridge, we have rigid frame bridge, and we have suspension bridge. The last two, the rigid frame bridge and suspension bridge, these are modern form of bridges, and you can suspension bridge you can find everywhere. And these rigid frame bridges, they are in India, they are mm, mainly used by Indian Railways. And arch bridge, again, this is the form of arch bridge. Next, as per construction materials, सीमेंट कंक्रीट ब्रिज, किस क्या मटेरियल आप इस्तेमाल कर रहे हैं आपका ब्रिज कंस्ट्रक्ट करने के लिए. सो सीमेंट कंक्रीट ब्रिज, मैसनरी ब्रिज, steel bridge, and timber bridge. Our focus is going to be on cement concrete or reinforced cement concrete bridge in this course. Now, as per the use, what is the use for this bridge? So road bridge, if motor traffic is crossing that bridge, then it's going to be a road bridge. If railway traffic is passing through that bridge, then it's a railway bridge. कुछ ब्रिज होते they have two decks, upper deck and lower deck. In either of deck you can see शायद या तो ऊपर से ट्रेन पास होती है या नीचे से ट्रेन पास होती है, और या तो ऊपर से ट्रैफिक जाता है या नीचे से ट्रैफिक जाता है. So that is road cum railway bridge. And then there is pipeline bridge. These bridges, they are not used by these bridges are not used by traffic. These bridges are just only there to carry a pipeline from point A to point B without losing the gradient. Pipeline का gradient lose नहीं होना चाहिए, और एक point से दूसरे point जो obstacle है, जिस obstacle की हम बात कर रहे हैं, उस obstacle को वो cross करके दूसरी तरफ निकल जाए. That is what pipeline bridge. And pipeline bridges are getting more and more important these days because of petrochemical industry. Next comes as per the span. आपका कितना span आपको क्रॉस करना है? What is the distance between the banks of, let's say, river? So depending on that, culvert, then comes minor span bridge, then comes major span bridge, and finally long span bridge. Now here, how can you define between culverts, minor bridges, and major bridges? So up to 6 meter, if span is up to 6 meter, then that structure is going to be termed as a culvert. If span is between 6 meters to 30 meters, then you can call it a minor bridge. And if the span is over 30 meters, then it is going to become a major bridge. Now, as per IRC, Indian Road Congress, road bridges and culverts are classified according to the loading. आपके bridge के ऊपर how much load that bridge is going to bear at a certain time, at a given time. As per that, IRC defined 3 classes for bridges in India: class AA, then class A, and then class B. Next, IRC is Indian Road Congress. Second, after Indian Road Congress, Indian Railways is the major corporation which has how to say which construct and operates far more number of bridges, right? So as per Indian Railways, there are major bridges, minor bridges, and important bridges. How to define them? Major bridges, total waterway more than 18 meter or having any span or clear waterway of 12 meter or more. So up more than 18 meter, it is going to be a major bridge. Then comes minor bridge. What is minor bridge? How to define it? If the span is less than 18 meter. If span is less than 18 meter, then it is going to be a minor bridge. And for important bridges, those bridges having total waterway of 18 meter or more. There is a little bit ambiguity between important bridges and minor bridges. Uh, there are other factors involving when it comes to important bridges, but when it comes to the span over which the bridge is crossing, that is same, 18 meter or more. So, and these classifications are important in order to to govern to operate these bridges. That's why these classifications are important, and we have to keep it in mind. So now let's move on to component of bridges. These are main components of a bridge. Let's start from the bottom. What we have is, first of all, what we have is footing. Of course, for any structure, for any civil structure, we have to have footing. Footing can be in form of piles, or if uh, if river is not perennial, so you can go for another type of footing. But in case of perennial rivers, it's always piles or caissons. So this is footing. After footing, what we have is bearing, then your columns. On columns, the girder is resting on this column, and these girders are carrying the deck, and this deck is the only part of bridge which is usable, right? You are only using the deck, and the rest of this structure is just to support that deck. So from top, let's see, this is parapet. दोनों तरफ जो, how to, I don't know the word in Hindi. Parapet, then there is deck on which traffic is moving, or pedestrians are moving. Then comes bearing. Bearing is the point on which this deck is resting. आपका जो डेक है, जो मेजर सारा जो मूवेबल लोड जो बेयर कर रहा है, वो डेक किस पॉइंट पे गर्डर पे रेस्ट कर रहा है, that is called bearing. And when it comes to bridge design, bearing is a very important component. Bearing is a very important component because bearing is the point of contact between a deck and the superstructure of a bridge. So it is a very significant component, and we have to there is a separate design for these components for bearings.
हेलो सर.
Next.
हेलो
Yeah.
सर, एक क्वेश्चन था छोटा सा.
Yeah.
सर, ये बियरिंग होता है सर, जिसपे हमारा डेक जो रेस्ट कर रहा है, तो हम लोग डेक को सर ऐसा क्यों नहीं किया जाता है कि डायरेक्ट उसको पियर कैप पे ही रेस्ट किया जाए? बियरिंग का क्यों जरूरत पड़ता है सर? वो छोटा सा स्ट्रक्चर एक पार्ट जो है, इसके बारे में.
बियरिंग का ओके, बियरिंग का जरूरत इसलिए पड़ता है क्योंकि आपका जो ब्रिज का जो डेक है, इट इज एक्सपोज टू द एलिमेंट्स, राइट?
यस सर.
इट इज एक्सपोज टू द एलिमेंट्स. और आपका जो नीचे का गर्डर है, अगर आप गर्डर की बात कर रहे हैं, तो दैट गर्डर हैज अ फिक्स स्पान.
यस सर.
But the deck is exposed to the elements, so and it's a concrete deck. Let's assume it's a concrete deck.
यस
So
सर.
what is going to happen because of nature, because
सर,
of
वो
the
टेम्परेचर का जो वेरिएशन होगा उसके
right
चलते क्या?
temperature का variation, एक तो ये point होता है.
जी
Second
सर.
thing is when the traffic is moving on this deck,
यस
if
सर.
heavy traffic is moving on this deck, that
तो
is
लोग.
also going to create some vibration,
यस,
right?
यस सर. यस सर.
So अगर वो वाइब्रेशन लगातार आपके कॉलम में जाता रहेगा तो क्या होगा? Either
अच्छा.
you have to design your column to resist these vibrations, which is
यस
not
सर।
going to be very economic. Okay.
ओके।
एंड उसके अलावा हम क्या कर सकते हैं, हम ये कर सकते हैं कि हम उस वाइब्रेशन का कंपोनेंट लीस्ट लीस्ट कर अमाउंट हमारा कॉलम में जाए, हमारी कोशिश ये रहनी चाहिए,
जी
राइट?
जी जी, बिल्कुल
So
सर।
that is why we are providing these
बियरिंग।
bearings. We have to
ओके।
design these special structure कि जहां पर आपका, because the joint between a deck in modern bridges, the joint between the deck and the
गर्डर।
superstructure of a bridge,
ओ।
it's always uh, it's on hinge. It's not fixed. It's not rigid.
ओके सर।
Clear है?
यस सर, समझ गया। ओके, थैंक
Okay.
यू सर, थैंक यू सो मच।
So okay, next is, yeah. So these are the components. Now these components are, you can group these components in we can say three families or three groups. So first one is foundation components, which is again, of course, all sorts of foundation. Then comes structural components. These are the bearing points. This is the bearing point. Everything below bearing point and above foundation is called structural components. And then above bearing, we have deck. Basically, what we have above bearing is a deck, and deck is called superstructural component. So these are major components of a bridge. So this is a brief intro of this course. Now, if you people have any questions, any queries, you can ask me. No queries?
सर ब्रिज डिजाइन के लिए मतलब सैप ही सबसे बेस्ट, मतलब
No, 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 no. That is not the case. That is not the case. SAP is one of the softwares you can use for in order to design a bridge. Understand? It is not the only software or the best software. It is by far. I can't say it's a best software. No, but uh, it's a tool you can use in order to design and analyze a bridge. Or the thing is that SAP is, what I think about SAP is like Stat Pro. Understand? So it
यस।
has, you can design everything using SAP. I find SAP to be like unlimited. उसका जो efficiency है वो unlimited है. But if you are talking about specific bridge designing software, so let's talk about, if we are talking about SAP is from CSI,
यस
the
सर,
company which is
जस्ट
manufacturing.
ई
Yeah,
टैब।
yeah. So these CSI, they also have CSI bridge, that is especially for the purpose of bridge. But what I understand is, my understanding is like, the e-tabs is just a component of SAP. एक SAP का एक कंपोनेंट लिया जिसमें से फ्रेम स्ट्रक्चर का सारा चीज डाली, उसको थोड़ा एनहेंस किया, एंड नाउ इट इज कॉल्ड ई-tabs. ऐसे ही SAP का जो ब्रिज का पार्ट लिया, उसे और एनहेंस किया, उसके ग्राफिक्स को ज्यादा अपीलिंग बनाया, एंड नाउ इट इज सीएसआई bridge. So SAP is, you can say it's like a mothership in when we are talking about CSI. Same is the case with StatPro.
Sir, I have a question.
Yeah, please go on.
Sir, can we get a demo how to do um, bridge designing in SAP?
If you want that demo, you have to, please talk to Protrainy people. If they,
Okay.
yeah, it can be arranged, but you have to talk to them first. I haven't include that particular thing right now, that particular aspect of this course in this demo class, because in order to get to that, आपको बहुत सारा कुछ करने के बाद हम final जो phase है वो है हमारा software के ऊपर. So it is not included in this demo right now, but you can talk to them, and it can be it can be it can be planned. No problem there.
Okay, okay, sir. Thank you.
Any more queries? regarding the course,
सर इसमें जितने टाइप्स ऑफ ब्रिजेस के बारे में आपने सब बताया, तो इस कोर्स में मतलब फोकस मतलब मेजर जो ब्रिजेस यूज हो रहे हैं इंडस्ट्री में, सिर्फ उस पे मतलब बात होगी या सारे टाइप्स पे सर, क्या
नहीं,
रहेगा?
आपको ब्रीफ डिस्क्रिप्शन तो सब टाइप्स का दिया जाएगा,
जी।
right? But when it comes to analysis and design, so we are going to concentrate on reinforced concrete bridges, whether it's a pre-stressed or
और
cast in situ.
रीइंफोर्स।
Cast in
अच्छा।
situ, it's irrelevant, सारा कुछ इसमें include होगा, but major जो है वो उसके लिए. Why is that? Because uh, I'm sure you people know कि अभी right now how much infrastructure sector is booming right now.
यस सर, यस
And
सर।
if you are aware, if you have accounts on LinkedIn, you can see that everybody is asking for bridge engineers or highway engineers.
यस सर।
So that's the case. So what we are trying to do is we are trying to provide you training which can help you to get a job as soon as possible, right?
यस सर।
So that is why we are going for reinforced concrete bridges. That is going. We are going to. That is going to be our main emphasis in this course. And frankly speaking, you can't cover all the bridges just in 30 days.
यस सर।
It's
यू
not
आर राइट।
possible at all. You need at least 1 to 2 semesters in order to cover everything regarding bridge. And the thing about why I'm using SAP 2000 for this course is that if you get well versed with the use of SAP, I'm sure you can design a bridge using any software available in the market. That's what I think. After using SAP, if you are okay with, if you are familiar with SAP, you can design using any other tool available in the market. Anybody else? We have a few more minutes. If you have any query, please go on. Okay then. So should we conclude? Okay. Nice having you all. I hope to see you all from 9th of September. Good night.
ओके सर, गुड नाइट।
Good night, sir.
Good night, sir.
Good night, sir.
Good night, sir.
Okay, who is this? Who is this moron? Rohit Kandapal, I guess. Please don't let him in the course. This Rohit Kandapal guy, don't let him in.